In B we have the same function f, and now the question is, f is a continuous function, but is it differentiable at x is 0? Well, the definition of a derivative in 0 is f prime 0 equals to the limit of h going to 0 of the differential quotient fh minus f0 divided by h. So the question is, does this limit exist? Well, we try to calculate it. The limit of h going to 0 of fh minus f0 divided by h minus 0 equals a limit of h to 0, and here again we have the fact, we may use the fact that h is not 0, so fh is actually this part of the definition of f divided by h, which is, if we take the proper terms together, h minus sinus of h divided by h squared sine of h, a trick that we use in part 2a. So now plug in h and we see that the numerator vanishes and the denominator vanishes, so we may apply L'Hopital here. You might check that. So we get a limit of h to 0 as the derivative of the denominator, which is 1 minus the cosinus of h divided by 2h sinus of h plus h squared times the cosinus of h. Okay, let's continue. It's going to be a little bit nasty, as you will soon find out. So we'll repeat the terms that we had. And again, this is a 0 above 0. 1 minus the cosinus of 0 is 0. And since the sinus vanishes and h vanishes, the numerator will vanish as well. So here again we apply L'Hopital, and the derivative of the numerator is sinus h, and you might easily check, well, this is a naughty part of in this exercise, that the derivative of the numerator becomes a little bit complex. Again, you see, since sinus of h and h vanish for the values h is 0, that we may apply L'Hopital again. Taking derivatives, we see that numerator and denominator are given as follows. You actually need a lot of paper to complete this exercise. As you will see, you may check that what we do here is correct. Take a break, pause the film, and you will see that you actually get these terms here. So now we may see that the cosinus of 0 is 1, and not every term vanishes in the numerator. So now we can actually calculate the limit as 1 over 6. So the limit exists, and therefore the function is differentiable in 0, and especially we have that the derivative in 0 is 1 over 6.